Hello and welcome everyone. In this podcast we're going to talk about the structure of the tRNA molecule. We'll talk about the enzyme that places an amino acid at the 3' terminus of that tRNA structure, and we'll define the differences between charged and uncharged tRNAs. And then we'll finish the podcast by talking about ribosomes. So let's begin by looking at a tRNA molecule. We'll write the 5' here and then the 3' over here. It forms several of these stem loop structures that we've seen as we talked about the termination of transcription. So remember, this 3' end here has a hydroxyl group on it. It's a 3' hydroxyl group. You need to know a couple features about this tRNA. You need to know that at the bottom here of this base, this is the anticodon that we've already talked about. It has 3 bases, and those 3 bases align with the codon of the messenger RNA during translation. You should recognize as each of these as stem loops, and that this region up here where the 3' hydroxyl comes off, you should recognize that as the acceptor domain. Acceptor because it is where the amino acid will join at. As I have this tRNA drawn right now, we would call it an uncharged tRNA. It becomes a charged tRNA when we place an amino acid at the 3' hydroxyl end. So if we remove the hydroxyl group and we add a specific amino acid to it, now it becomes charged. That's the only difference between a charged and uncharged tRNA. The charged one has a specific amino acid attached to it that matches up with the anticodon. So how does the amino acid make its way to the tRNA at the 3' hydroxyl group? It does so by using a specific enzyme, and I'll just draw it like such. This enzyme will bind ATP and specific amino acids, and we'll say in this case is proline. This enzyme recognizes that this tRNA is a tRNA that codes for, say, proline. So let's say down here it's G, G, G. That's the anticodon that codes for proline because the codon would be C, C, C. So this enzyme recognizes that particular anticodon and delivers proline to this 3' hydroxyl group. So we're going to add our proline here. And in the process, the ATP is lost and cleaved, releasing that energy, which is necessary to make this reaction work. So how many of these enzymes are present in a given cell? Is there one enzyme that is able to recognize all the different codons here, or anticodons, to deliver any given amino acid there, or is there a separate one for each amino acid? It turns out that there are 20 different ones. So 20 different enzymes. So these enzymes will bring in one of the 20 different amino acids to this 3' hydroxyl group. It has the ability to recognize multiple anticodons because there's more than one anticodon that will bring in proline. But there are 20 different ones. And the name of this enzyme, I haven't mentioned it yet, is aminoacyl tRNA synthetase. So to recap, before it has the amino acid, we call it an uncharged tRNA. That uncharged tRNA can become charged by an enzyme called aminoacyl tRNA synthetase, which brings in a specific amino acid that's linked to the correct anticodon to make it a charged tRNA. It turns out that these enzymes are incredibly efficient. They sometimes make mistakes, but not often. It's about once every 100,000 times it places an amino acid there. You don't have to remember that number. It was just to demonstrate how accurate and faithful this enzyme is. Okay, next I would like to talk about the ribosome. So let's erase this. Alright, let's talk about the ribosome now. Your book spends quite a bit of time talking about it, but I want you to just know some basic features of it and some differences between bacteria, and eukaryotes. In general, we can think of the ribosome as being composed of a large subunit and then a smaller subunit. And we know that the messenger RNA gets fed in between these subunits. And it is fed through here going in 5' to 3' direction. This is the first time we've seen a nucleic acid read in the 5' to 3' direction. Now there are 3 specific sites within this large subunit that we should talk about. They are the E site, the P site, and then the A site. I always remember that because it sounds like EPA. The 2 most important are the P and the A site. The P stands for peptidyl, and the A site stands for aminoacyl site. We'll see on the next podcast that these sites are really important for the tRNA to bind into, to deliver that amino acid that needs to come in here. The E site, I should mention real quick, just stands for exit. It's where the messages go, the tRNAs go to as they leave the ribosome. Your book describes many differences between bacteria and eukaryotic ribosomes. This is what I want you to know about the differences between these 2. And I'm going to erase this down here. And that is that in bacteria, and eukaryotes, the size of the actual parts of the ribosomes, large and small, are different. In bacteria, the small subunit, I'll put it in purple to match the small subunit here, is 30S, and S stands for Svedberg units. It's based upon the density or buoyancy of the structure here. The large is 50S. When you combine these, you end up with something that is 70S. The eukaryotic small ribosomal subunit is 40S, so it's a little bigger, and the large is 60S. And together, they are 80S. You should also know, and I'm going to write it over here, just so we have a place to put it, that these ribosomes are made up of proteins plus ribosomal RNA molecules. And we'll talk more about these ribosomal RNA molecules, but I want to write down a really important one. And this really important one is called ribozyme. It's an RNA molecule, but it functions as an enzyme, and its function is to form that peptide bond between a developing amino acid chain. Okay, that's all I have for this podcast. Let me summarize real quickly what we talked about. We talked about the tRNA structure. You should be able to draw the tRNA. You should be able to label the parts of the tRNA. You should be able to talk about where that amino acid binds, so you should know the difference between charged versus uncharged, and how an uncharged tRNA can become a charged one using the aminoacyl tRNA synthetase. We talked about how there are 20 of those enzymes in a cell to help deliver 20 amino acids to those tRNA. And then we ended talking about the ribosome. We talked about how the ribosome has a large subunit, a small subunit, and how it reads the messenger RNA to make an amino acid chain. We talked about the relative size of those small and large subunits. And finally, we also mentioned that those ribosomal subunits are made up of a combination of RNA molecules and protein molecules. All right, that's all I have for this podcast. If you have any questions, please let me know. Thank you. Bye.